Welcome to Alias Wavefront and the world of 3D modeling, rendering, and animation. You are about to begin exploring an exciting suite of tools that give designers, animators, and other artists who specialize in digital media a means to let their creativity fly. This video is an introduction to the basic tools and techniques that you will be using to create your designs and animations. The first part of this video is an introduction to the new version 7 interface. You will learn how to find and use tools and to begin working in a 3D environment. Customers upgrading from version 6 should pay special attention to this section since the user interface has changed significantly from previous versions. After the user interface, you'll learn about how to create 3D models using primitives, curves, and surfaces. Next, the video explores the creation of shaders and textures and the lighting of a scene. The final section of this video will explore animation basics such as setting keyframes and using hierarchies. Version 6 customers should watch all of these sections since changes to workflow and cool new user interface features are frequently being introduced. While watching this video, it is not necessary for you to follow along on your computer. The ideas taught in this video are expanded upon in the Level 1 Learning Alias tutorial guide, where you will get hands-on experience with your system. To help you with this video, special graphics will be used to explain mouse clicks and keyboard shortcuts. As shown below, the SGI mouse has 3 buttons. In most cases, the left mouse button is used. In other cases, you can use the middle and right mouse buttons for added functionality. If you are told about a click and no mouse diagram is shown, then you know that the left mouse button has been used. Another diagram that will pop up from time to time will be a keyboard diagram that shows you when the Shift, Control, and Alt keys are being used. In most cases, the keyboard and mouse diagrams will be shown together so that you can see how they work together. Before diving into the user interface, let's pause and take a look at the 5 main steps involved in creating a 3D rendering or animation. Using a simple example, you can see how each step affects the final look of the design or animation. Modeling is the first step in the process. Modeling is where you create surfaces and combine them into 3D objects. You will then apply shaders and textures that will add color and materiality to your scene. Next, you will set up lights that will illuminate the scene and set the mood of the upcoming rendering. Rendering is akin to taking a photograph of the scene. The rendering combines the geometry, lights, and shaders to create a final image. A raycast rendering uses color, light, and shadows to create the final image. For photorealistic images, Alias also offers ray trace rendering, where you can use reflections and refractions to bring the scene to life. Animation can then be used to add motion to the scene. You can animate the camera to move around your objects, or you can animate the objects to make them come alive. Most of your projects will be broken down into these key steps. This video focuses on these steps and some of the main tools used to create the desired results. There's a lot to learn, so let's get started. Let's start by looking at the menu bar. The menu bar contains alias functions that do not result in direct manipulation in the 3D modeling world. These menus follow the motif standard that will be familiar to those people who have worked with other programs on their SGI system. To pick a menu item, you can start by using a click-drag action. Click on the Layouts menu name and drag down to the top function. When you release the mouse button, the function will be executed. In this case, the workspace is now filled with a full-screen, top-view window. Menus can also be posted to give you more time to think. Click once on the Layouts menu name. This posts the menu and gives you a chance to make a selection. Click once on the All Windows menu function. Since this item has an arrow beside it, a second hierarchical menu is posted. Click on All Studio. This executes the new window function. There are now 4 view windows in the scene. As you work, you can choose between the click-drag approach or the posting approach when choosing menu functions. The first method is faster, while the second gives you more time to think about your selection. If you want to pick the last menu item used, a trick is to simply double-click on the menu's name. This will re-evoke the last menu item as needed. While exploring how to work with menus, you open several view windows that are used to look into the virtual 3D environment in which you build and animate your models. In Alias, view windows are treated like objects and can be saved or deleted. From the Delete menu, select Delete All. Click Yes to complete the action. The 4 view windows are now removed. Now let's use a new window layout. From the Layouts menu, select All Windows, All Vertical Perspective. This creates a new window layout that shows the 3 orthographic windows at the left with 1 large perspective window at the right. The All Windows menu contains several layouts that you can use to view your objects. Moving to the left side of the screen, you will find the Tool Palette. The Tool Palette contains those tools that require direct manipulation in the view windows. Alias has a large number of tools that can be found under various subsections within the palette. Click-drag on the scroll bar to the left side of the palette to scroll down to the Object section of the palette. In the Object section, you will find a number of tool icons ready to be used. Depending on which Alias wavefront product you are working with, the Object section shown may include a few less tools than you see in the video. Click on the sphere icon with the middle mouse button to see the name and path of the tool. A black box appears indicating that the tool is the sphere tool and it is in the primitives path. You can use the middle mouse button to help you learn the meaning of the tool icons. Click on the sphere icon with the left mouse button to select this tool. The icon is outlined in red to show the tool is selected. Click in the top window to place a sphere into the 3D workspace. It will be visible in all the view windows. Some of these tools are not immediately visible in the palette. These tools are hidden under other tools and are labeled using a yellow arrow. Click and hold on the sphere icon. This displays all of the primitive tools that are hidden underneath. Click on each tool with the middle mouse button to see what their names are. Next, click on the Cube tool and release. The Cube tool is now the top tool in the Primitives area of the Objects section. Click in the top window to place the cube into the scene. So far you have seen all of the tools displayed as icons. If desired, you can close the sections of the palette to hide these icons. Click once on the Objects tab using the left mouse button to close this section. Repeat this action on several other tabs to close them as well. In your work, you may want to keep the palette sections closed so that you can easily find the section names. To access the tools within a section when it is closed, you can either reopen the section or access the tools using the right mouse button. Click once on the Objects tab using the right mouse button. This posts a menu version of the Objects section. Click on the Primitive section to post a second menu. Click on Cone to pick this tool. Click anywhere in the top window to place the cone in the scene. As you can see, tools can be accessed as menus if you don't want to open up the palette sections. Some tools and menu items have options that allow you to set how the tool works when it is used. The option window is indicated using a square box with a drop shadow that can be found to the right of a menu item's name or in the top left corner of an icon. Click once on the Objects tab using the right mouse button to post it. Click on the Primitive section to post this menu, then click on the square button next to Cylinder to open the cylinder options. This opens an option window that lets you edit special settings for the tool in question. In this window, double-click on the field next to Sweep and change the angle to 180 degrees. Version 6 users should note that entering text now conforms to motif standards. Change the sections to 6. Click Save. This saves your settings without actually using the chosen tool. As well as opening up an option box using the Tools menu, you can also double-click on the Tools icon. In the Tool palette, click on the Objects tab to reopen this section. Click and hold on the Primitives pop-up and then select the Cylinder tool. It should now be the top primitive tool in the palette. Double-click on the Cylinder tool icon. This is a second method for opening option windows. Change the settings back to their defaults by clicking on the Reset button. Click Go. Then click in the top window to place the cylinder into the scene. Version 6 users may notice that their favorite tools have been moved, and with the new icons it may be hard to find their new locations. Version 7 includes a special online find function designed for the upgrading customer. From the Help menu, select the Help Find V6 function. The Help window appears, offering you all of the old version 6 menu levels. As an example, let's try to find the old Copy function. Since the Copy function was in the version 6 Model menu, click on Model. After a short delay, click on the Copy function from the old Object Tools menu button. The tool has been renamed Duplicate Objects, and it is now under the Edit menu. You also find out that there is a new Copy tool that is also found in the Edit menu. Next, click on the Skin menu function from the Build Surface menu. This time you find that the tool is in the Ruled Surfaces subsection of the Surfaces section of the tool palette. If you want to keep this window around to learn tool locations, you can minimize it for easy access. For now, let's close it. With this online assistance, the locations of all the version 6 tools are at your fingertips. You can also use the Help menu to access online docs containing all of the text and images from the printed manuals and also the tutorial lessons. Now that you know where the tools are and how to access them, you can begin looking at the tool shelf. This window is found at the bottom of the screen and at first seems to be a duplicate of the tool palette. The difference lies in the fact that while the location of tools are predetermined in the tool palette, you have control over their location in the tool shelf. Already you may notice how the tools and sections in the video differ from the tool shelf on your computer screen. This is because the tool shelf can be personalized so that it contains your most used tools. Let's start a new shelf. From the Options menu on the tool shelf, select New Shelf. In the New Shelf name window, enter My Shelf and click OK. A shelf is created. Click on the new shelf to bring it forward. It is currently empty except for the Delete icon area. In the tool palette, scroll down to the Objects section. Click and hold on the Text tool with the middle mouse button. Drag the black name box down to the tool shelf and release onto the empty area of the shelf. This tool is now added to the shelf. Click and hold on the Cylinder tool with the middle mouse button. Drag the black name box down to My Shelf and release. Click on the Windows menu to post this menu. Click on the Multi-Lister submenu to post it. With the middle mouse button, click and hold on the Shaders menu item. Drag the name box down to the shelf and release. Now the menu item is shown on the shelf, since you can add both tools and menu items to your tool shelf. Once you have several tools on a particular shelf, you may want to reorganize their position. To move an icon within a shelf, you can simply drag it to a new position. With the middle mouse button, click on the cylinder icon in the shelf. Drag its name box to the right of the shaders icon and release. The shader icon is now in the middle of the other two icons. This method of moving the icon position can be used for all tools except for the trash can icon. To move an icon to another shelf, you can drag the name box onto the tab for that shelf, even if the shelf is not highlighted. Just like the tool palette, tool shelf tools can be accessed as menus. Click on the tab of My Shelf with the right mouse button. Your three icons are now displayed as a menu list. This is a fast way of using tools that belong to one of the hidden shelves. From time to time, you may want to edit a shelf by deleting an icon. To delete an icon, click-drag on the text icon with the middle mouse button. Drag the black name box onto the trash can icon. The text icon is removed from the shelf. You can also rename a tool shelf by editing its tab. Double-click on My Shelf, Shelf tab. In the naming window, enter Lesson 1 and click OK. The shelf is renamed. Let's add some more tools to the shelf. In the tool palette, scroll up to the Pick section. Use the middle mouse button to find the tools. Drag the Pick Nothing, Pick Object, and the Pick Component tools down to the shelf. You'll use these tools later in the lesson, so you can keep them on the shelf for easy access. You are now going to add another cylinder icon to the shelf. This will allow you to have a second version of this tool that has different settings than the first. Click-drag with the middle mouse button on the cylinder tool to drag a second icon to the shelf. Double-click on this new cylinder icon in the tool shelf to open its option window. Change the sweep to 180 degrees and click Save. You now have two cylinder icons in the shelf, which each create different types of cylinders. Whenever you have more than one version of a tool on a shelf, each icon can have its own settings. You may ask yourself, but how do I tell these tools apart? You can edit the look of the tool shelf icon using a paint program called Xpaint that can be loaded directly from the tool shelf. Hold down the Alt key and double-click on the new cylinder icon. After a short delay, Xpaint opens with the icon loaded. This application allows you to edit the look of the icon using various pixel-based paint tools. In the case of the half cylinder, you can start by adding text in the corner to indicate a 180-degree angle. You can also pick up one of the existing colors in the icon and use it to paint away half of the cylinder. It is not necessary to always edit the icons to this detail. The level of editing you apply to the icon is up to you. When you have finished, choose Save As from the Xpaint file menu. Make sure that you choose SGI format from the Xpaint file browser and click OK. Close Xpaint and its tool palette. Back in the tool shelf, click on the icon and it will be updated to display the results. This editing process can be applied to any icon that is on the tool shelf. The tools in the tool palette cannot be edited using this method. Using Xpaint, you can truly customize the look of your tool shelf as you begin adding information to your various icons. Once your tool shelf is fully customized, you can save it for future reference. Click on the Option menu on the right side of the shelf window to store or retrieve shelf settings. You may find that you have several different shelf setups that you want to keep on hand. In addition, Alias ships with several default shelf sets which are based on our research into the tools most frequently used by various types of users. Later, you may want to explore these shelf setups as a starting point for creating your own shelves. So far, the tools in the palette and shelf have been displayed as medium-sized icons. There are several alternative display options that let you see these items as either text or icons of varying sizes. Again, you are in control, since the look of the user interface is decided by you. From the Preferences menu, select the Interface options. Click the Show Icon Labels option to turn it on. Click Go. The icons now display labels to help you learn the tool names. Again, open the Interface options. Change the icon mode to small and turn the labels off. This will create small versions of the icons that will no longer display text labels. The tool icons in both the shelf and the palette are now shown as small icons. As you become more familiar with the icons, this icon mode lets you see more tools on the screen at one time. Now, reopen the Interface options. Change the icon mode to text and click Go. The tool icons in both the shelf and the palette are now shown as text buttons. Again, go to the Interface options. Change the icon mode back to medium and click Go. The tool icons are returned to their default size. In your work, you may want to test which icon mode best suits you. Another way of customizing your user interface is to change the placement and orientation of the shelf and palette. On the tool shelf, select the Orient button next to the Option menu. This reorients the shelf tabs in a vertical organization similar to the tool palette. Use the scroll bar on the left to scroll between the various shelves. Click again on the Orient button to return the shelf to its horizontal orientation. You can position the tool shelf and palette anywhere on the screen using standard motif window manipulation techniques or by editing your layout by choosing Palette Layout from the Preferences menu. In the Layout option window, you can have a vertical shelf and a horizontal palette, or you can have both of them vertical. Once you position the shelf window in the workspace, the icons and tabs will orient to suit. As you work, you may want to play with different palette and shelf positions to see which ones you like best. To access tools from the keyboard without using either the palette, menu, or shelf, you can assign hotkeys to any tool or menu function. Click once on the File menu to post this menu. You will notice that beside functions such as Retrieve and Save All As, there are keyboard references. If you want to, you can perform these functions by pressing the labeled keys. Click away from the menu to close it without picking a function. To edit the hotkeys, you must go to the Preferences menu and select Edit Hotkeys. In this window, you can add to or edit the hotkey settings. Close this window for now. Later, when you know what your favorite tools are, then you can begin assigning hotkeys. In addition to the shelves and the tool palette, Alias includes a special type of menu called a marking menu that gives you another means of access to frequently used tools. A marking menu is a floating menu that appears at your cursor when you press the Control and Shift keys in combination with a mouse click. To call up a marking menu, press the Control and Shift keys, then click and hold anywhere with the left mouse button. A radial marking menu appears with 4 tools displayed. You can pick one of these tools by dragging in its direction. Press the middle mouse button to bring up a second set of tools, and then the right mouse button to bring up a third set of tools. Again, use the left mouse button and use the marking menu to choose the Pick Object tool. Click on the cube in the top view window. The advantage of marking menus is that as you become more familiar with the layout of a particular menu, you can use a faster motion to intuitively pick in the proper radial direction. Press the Control and Shift keys and click-drag quickly in an up direction and release the mouse button. A black line is drawn, but no marking menu appears. You have just used the Pick Nothing tool without actually seeing the tool in the workspace. Once you become familiar with the radial position of the marking menu tools, a quick click-drag gives you intuitive access to these functions. To edit the tools available on a particular marking menu, go to the Preferences menu and choose the Edit Marking Menus function. This opens a special tool shelf that will allow you to set up your own marking menus using up to 8 tools. You can see that each of the tools that you saw in the marking menus has their icons in this special shelf. You can add to, delete, or reposition any of the tools on these shelves and therefore on the marking menus themselves. So far you've looked at how to place objects, but what if you want to get rid of some of them? Alias includes several delete functions to remove objects, lights, and windows from your workspace. To delete the cube and the cone, select Pick Object and click on the cube. From the Delete menu, select Delete Active. At the prompt, click Yes to delete the cube. With Pick Object still selected, click on the cone. Press the Delete key on your keyboard. This evokes the Delete Active function. Again, click Yes to delete the cube. This delete key is a permanent hotkey that you can use to speed up the deleting of objects. Now, go to the Delete menu and select Delete All. At the prompt, click Yes to delete everything from the scene. This action deletes all objects, lights, and even view windows. Since you are about to retrieve a wire file that contains its own view windows, you needed to delete the existing ones. You are now going to begin retrieving wire files so that you can work with existing projects. When you work with Alias, these files are saved in special directories known as project directories. A project is used to keep associated files in one place. From the File menu, select Retrieve. This opens the File Lister. This window allows you to work with your project files. Click on the Show List button. You are now in the wire directory that belongs to the demo project. Click on the diagonal arrow to the left of the word wire. A list of directories is shown within the demo project. These directories contain the various files associated with the project. These directories should not be deleted or changed because Alias refers to them as you work through a project. Next, click on the diagonal arrow to the left of the word Demo. This takes you to the user data directory where all of your projects are stored. Click on the name Courseware to highlight in white. With the Courseware project directory selected, go to the Project menu and select Set Current. The Courseware wire directory is now the top level of the lister. Alias will now load and save files to the Courseware directories automatically. Now that you are in the Courseware project, you'll retrieve an existing wire file. Wire files contain all the geometry, materials, and animation information for your Alias models. Click the Lesson 1 Objects icon in the lister and then click the Retrieve button. This retrieves the wire file into Alias. You could have also double-clicked on the icon to retrieve the file. You are now going to explore how your modeling view windows work. These windows give you access to your 3D modeling world. When the wire file was opened, it appeared with the standard layout of 4 view windows. Any one of these windows can be moved around and resized. Turn your attention to the perspective window that is located at the top right of the screen. Click-drag on the Resize button with the left mouse button at the bottom left of the window. Drag out to make the perspective window bigger on the screen. Sometimes you need a larger window to work with geometrical details. Now click-drag on the blank part of the title bar of the window and move it around the screen. Sometimes you need to move a window so that it doesn't conflict with another window or option window. To find out more detailed information about the window, click the Window Info button. This lets you see the positioning and resolution of a window. Change the X width of the window to 800 pixels. Now close this window by clicking on the Close button. To set the window to a preset resolution, click on the word Free in the title bar of the perspective window and drag down to NTSC to size the window accordingly. It is now exactly 645 by 486 pixels. With this menu, you can set your window size to a series of defaults. Now, click on 645 by 486 and drag down to Free Default. The window is now its original size. From the Layouts menu, select All Windows, All Studio to return the window to its original position. Another way of retrieving wire files is to merge the information into an existing file. This can be a useful method of starting with several smaller models that are then brought together into a larger scene. From the File menu, select the Retrieve options. In the Wire Options section of the window, set the Keep Windows, Cameras, and Background buttons to Off. Click Retrieve. This ensures that you don't place new windows on top of existing windows and that you don't create a new camera. In the File Lister, click on the file named Lesson 1 Objects 2 and click Retrieve. This adds 5 spheres and a light into your existing scene. Now that you know how to move and resize the actual view windows, you can turn your attention to methods of changing how each window displays the objects in your scene. As you can see, the 4 view windows display the geometry from several angles. By default, the geometry is seen from the top, front, right, and in perspective. The first 3 views are orthographic and present a draft person's view of the geometry. The perspective view, on the other hand, gives a true 3D view showing spatial relations of the model. You may note that while the curved surface seems to sit on the ground in the perspective window, in the front window it is below the ground level. When positioning objects in 3D space, using several views in combination is the best way of ensuring that you are positioning your objects properly. You are now going to change how each window views the objects in your model. Note that these view changes will not change the positioning of the objects, but rather how you are looking at them. Click anywhere in the top view window to make it active. 3 stars appear in the title bar to show it is the active window. Now scroll down to the Cameras section of the tool palette. Find the World Move Camera Dolly tool within the Cameras section. Click and hold with the left mouse button to dolly into the top view window. Release the mouse button to stop the view change. Next, click and hold with the right mouse button to dolly out. Now click-drag quickly in the top window at the center of the objects. A view marquee appears. When you release the mouse button, the view changes to the one selected in the marquee. Go back to the Cameras section of the tool palette and find the World Move Camera Track tool. Click-drag in the top window with the left mouse button. This lets you track the view in all directions. Now, click-drag up and down in the top window with the right mouse button. Your tracking is restricted to the vertical axis. Click-drag left and right with the middle mouse button. Now tracking is restricted to the horizontal direction. Individual mouse buttons affect how the camera tools work. You may want to try the different mouse buttons later to see how they affect on each of the tools. Another feature added for version 7 is the ability to synchronize the 3 orthographic views. This allows you to see these 3 important windows at the same size and scale. From the Display menu, select Toggle Window Sync. With the Track tool, click-drag in the front window. Watch how the left-right motion is picked up by the top window and how the up-down motion is picked up in the right window. Now dolly into the window to get closer to the objects. Once you are happy with the results, turn the toggle mode off. This toggle mode is very useful when you want to ensure that the orthographic views match up at all times. Version 7 also includes a new combined Track, Dolly, Tumble tool. This tool brings together the capabilities of the 3 main camera tools and lets you use modifier keys to choose which view type you are using. You can use this tool in place of the other 3 separate tools. Click on the title bar of the perspective window to make it active. From the Camera section of the tool palette, select World Move Camera Track Dolly Tumble. Click-drag with the left mouse button. The view tracks so you can see the scene from a different point of view. Now press the Control key and click-drag with the left mouse button to tumble in 3D. Next, Press the Control key and click-drag left and right with the middle mouse button. The tumbling is restricted to the vertical axis. Press the Control key and click-drag up and down with the right mouse button. The tumbling is restricted to a horizontal axis. Alias offers many ways of changing the camera in orthographic views. You can use this combined tool or the individual tumble, dolly, and track tools when you change views. You have seen how the camera tools offer several different ways of changing your point of view. The problem is that to use these tools, you must interrupt the use of another tool to change views. To enable a faster workflow, you can use the view icons found in the title bar of the view windows. These icons let you make view changes without disturbing the current menu function. For instance, to tumble in the perspective window, click-drag directly on the tumble icon found in the Windows title bar. Next, click-drag on the dolly view icon to dolly in and out of the scene. You can use the tumble, dolly, and track icons to get the various views in the perspective window or in the orthographic windows. The three mouse buttons can be used as you work with the view icons to constrain your views. Another important skill that you must learn is the ability to pick one or more objects to make them active. This helps you establish which objects you want to work with at any given time. Alias includes various pick tools that offer you a number of picking options. If you're familiar with version 6, you should note that the basic pick tools have new options. These new options use the different mouse buttons to make picking more versatile. Scroll up to the pick section of the tool palette. Select Object Types, All Object Lights. Now, all the objects and lights in the scene are picked. They are highlighted to show they are active. Now, select Pick Nothing. This unpicks all the objects and lights. Select Pick Object. You will now explore how different mouse button clicks affect the picking of objects. Click on one of the wire lines belonging to one of the spheres to pick it with the left mouse button. It becomes highlighted. With Pick Object still selected, click on the wire lines of two more spheres. They now are highlighted and added to the selection set. Click again on one of the spheres with the left mouse button. It is now unpicked or deselected. Now, click on a different sphere with the middle mouse button. Now the new sphere is picked and all the other objects are unpicked. The middle mouse button lets you replace a selection with a new selection. Next, click-drag with the left mouse button to create a pick box around the 5 spheres and the 3D text. The picked sphere is unpicked while the other objects are picked. Next, click-drag a pick box with the middle mouse button around the 5 spheres and the 3D text. All the objects are now picked. The difference between these picks is evident because the middle button replaces the old selection while the left mouse button toggles it. Next, click on the 5 spheres individually with the right mouse button. They are removed from the pick set. With the middle mouse button, click in open space on the working grid. This replaces the pick set with nothing. Using the middle mouse button to click in empty space is the same as using the Pick Nothing tool. You are now going to pick the text object as both a single grouped object and then as individual components. Select Pick Object and click on either the number or the letter of the 3D text. Since all the surfaces that make up the text have been grouped, it is picked as a single object. With the middle mouse button, click in open space to again pick nothing. Select Pick Component. Click on one of the wire lines that belong to the front face of the number 3. Only the chosen surface is picked, since it is a component of that text group. With the middle mouse button, click in open space to again pick nothing. Sometimes the modeling windows contain too much visual information and it is hard to discern one object from another. The Scene Block Diagram or SBD window offers a graphical inventory of your objects and their hierarchical relationship. From the Windows menu, select SBD. A window opens with icons representing the pieces of your model. With Pick Object selected, click on the 3D text in the modeling window. Click on the SBD window to make it active. Use the Track View icon in the title bar of the SBD view to alter the view. Keep tracking until you come across the picked text nodes in the SBD window. The 3D text is represented by several icons known as DAG nodes. DAG stands for Directed Acyclic Graph. The brown DAG nodes represent the positioning, scaling, and rotational information about an object. The blue surface and green trim surface nodes represent the actual geometry information, such as CV positions. Usually you'll use the upper nodes to work with objects, but occasionally you'll need to work with the lower nodes. In the case of the text, there are 3 levels to the hierarchy. The top node represents the whole string of text, while the middle node represents the 2 letters separately. The lower brown nodes represent the positions of the surfaces that make up the text, while the blue and green nodes represent the actual geometry. Click with the left mouse button on the leftmost view icon in the SBD title bar. This moves the position of the DAG node in the SBD window. Next, click using the right mouse button to move it back. Click drag on the dolly icon in the SBD title bar to dolly in to the SBD window. Dolly in until you see the text on the DAG nodes. Use the track icon so you can see the sphere DAG nodes. With pick object still selected, click drag a pick box around 2 of the sphere nodes with the left mouse button. In the modeling views, the spheres and the 3D text are now picked. This time, click drag a pick box around the 2 sphere nodes with the middle mouse button. The 2 objects are picked and the text is unpicked. Many of the same rules that apply for picking objects in the modeling views apply to picking in the SBD view. In the SBD view, click drag on the track icon to return to the text hierarchy. With pick object still selected, click on the node named D with the middle mouse button to pick it alone. In the perspective window, you see that you've picked the letter D separate from the number 3. Sometimes you want to work with the pieces of a DAG structure. You can do this in the SBD window using pick object or in the modeling views with pick component. Now click on the top node of the text. Since an upper and a lower DAG node cannot be picked at the same time, the node is unpicked in favor of the upper node. From the Object Display menu, select Compress SBD to compress the node into a single icon. This command simplifies your SBD view. From the Object Display menu, select Expand SBD to again make the lower nodes visible. Click drag to the left on the dolly icon to see more nodes in the SBD window. These nodes represent all entities in the scene. Close the SBD window. With Pick Object selected, click in open space with the middle mouse button to pick nothing. So far, the models you have been working with have been displayed as wireframe lines. Although wireframe models give you visual information about the shape of an object, the wire lines may not let you edit the parts of those objects or see the shapes as they react to light. Alias has various display options to give you greater control. From the display menu, select the control options. In the control window, set the scope to all and click on the All On button. Click Go. Now all the objects in the scene display CVs, hulls, edit points, and key points. You'll learn what these controls are in upcoming lessons as you use them to edit the surfaces of objects. In the control window, click All Off, then click Go. Close the control window. The controls have now been turned off. Another display option is to see your objects shaded. From the display menu, select Toggle Shade. After a moment, all 4 view windows show shaded views of the geometry. Use the Tumble View icon to see how the shaded mode works when making view changes. You can model in a shaded view and you can make view changes. From the display menu, select Toggle Shade to turn it off. You now have a basic understanding of several key elements concerning the new version 7 user interface. You have learned how to customize the look of the interface and can pick and use tools using several different methods. It is now time to begin learning how to create your own objects using curves and surfaces. In Alias, you will build models by giving shape and form to objects in a virtual 3D space. Modeling involves building objects out of primitives, curves and surfaces, then scaling, rotating, and moving these objects into realistic shapes. Starting with basic primitives, you'll be learning how to place and position objects in 3D space, then how to draw curves and create surfaces. Version 6 users should note that in this section they will learn about the new information window as well as new methods of picking objects when using the Xform tools. Let's start by exploring world space where your models will be placed. When you move objects around in 3D, they are being moved in a coordinate system that is defined by values in the X, Y, and Z directions. If you look in the bottom left of the three orthographic windows, you can see how these axes are defined for each view. The top window, for instance, looks down on the X and Y axes. The front window, on the other hand, looks at the Y and the Z axes. In the perspective window, the three axes are labeled at the origin of the world space. This point has a mathematical value of 0, 0, 0, and you will often refer to this point as you move and position objects. Primitives are basic shapes such as spheres, cubes, cylinders, and cones. Scroll to the Object section of the Tool palette and choose the Primitive Sphere tool. Please note that in this part of the video, the Tool palette will be used to find tools instead of the shelf. This is to ensure that you know the palette location of the tools. In your own work, you will want to take these tools and place them on the shelf. Type 0 space 0 space 0 and enter. This places a primitive sphere at the origin of the world space. Next, select the Cube tool. Click anywhere in the top window to place the cube on the ground grid. Alias lets you choose between keyboard or mouse input when placing objects. Select the Cone tool. Go to the area just below the right side of the menu bar and click on Grid to turn on grid snapping. Go to the perspective window and click to place the cone near the sphere. Because grid snapping was on, the insertion point of the cone will snap to the grid. Turn grid snapping off. The three primitives have now been placed in 3D space. In order to determine where they are, you can use the Information window. With the cone still picked, go to the Windows menu and choose Information window. The Information window appears showing the object's names and some section titles. Click on the Transform Info title to open this section. See how the cone has been placed at accurate XYZ coordinates because of the Grid Snap option. Click on the Z coordinate and change the value to 2.0. Press Enter. In the front view, you can see that the cone is now sitting 2 units above the ground. In the Modeling View windows, select Pick Object and click on the cube to make it active. The Information window updates to show this second object. Version 6 users will note how this window is an improvement over the old Model Stats window that did not update as a new object was picked and could only show one object at a time. Since the cube was placed freely, the Information window gives you access to the actual coordinates in which it was placed. This window also gives you values for the scaling and rotation of the object. In the Z value for scaling, enter 5. In the Z positional field, enter 2.5 to move the cube up. You will learn more about scaling and rotating in the next section of the video. For now, close the Information window. Translating, rotating, and scaling objects is an important part of composing a scene in Alias. These transformations, or X-forms, can be accomplished using either keyboard input or mouse actions. Click on the cube with the middle mouse button so that it is the only object picked. Scroll to the X-form section of the Tool palette and select Move. In the top window, click-drag with the left mouse button to drag the cube around. Watch it move in the other 3 windows. Now, click-drag with the middle mouse button. Watch how the cube is restricted to the horizontal. Now use the right mouse button to move in the vertical. These mouse button constraints work for the 3 orthographic windows. The perspective window works differently. With the X-form move command still selected, go to the perspective window. In this window, click-drag with the left mouse button. The cube moves in the X direction. Click-drag with the middle mouse button to move in the Y direction. Next, use the right mouse button to move in the Z direction. If you don't like a transformation, select Undo from the Edit menu. Now choose Rotate from the X-form section of the Tool palette. In any window, click-drag with the left mouse button. The box is rotating about the X-axis. As with moving objects in the perspective window, the middle mouse button rotates about the Y-axis, and the right mouse button rotates about the Z-axis. Click on the cone, then select X-form Scale. Click-drag in the perspective window to scale the cone in all directions. Return to the Tool palette and select the X-form Non-Proportional Scaling tool. With the right mouse button, click-drag in the perspective window to scale the cone in the Z direction only. The mouse buttons control the axes of scaling. When using the X-form tools, you often find yourself wanting to change which objects have been picked. In version 6, you could replace an Xform pick with another object without going back to the pick tools. In version 7, Xform picking has become more versatile since you can pick in the same manner as in version 6, and you can now use the Shift key in combination with different mouse buttons to create more complex pick operations. With the cone active, select the Xform Move tool. In the top window, click Drag to move the cone. Now click on the cube to pick it. You have replaced your original pick selection with the new object. Press the Shift key and click drag a pick box with the left mouse button around the cube and the cone. You have toggled the selection states of these two objects. Now, press the Shift key and click drag a pick box with the middle mouse button around the cube and the cone. Click drag to move the new selection. The middle mouse button allows you to replace the existing pick selection with the new selection. Similarly, the Shift key and the right mouse button can be used to remove an object from the selection set. By using the Shift key, you can use the mouse buttons to create selection sets without leaving your current Xform tool. Now that you have learned how to transform objects using mouse clicks, you should begin exploring the use of the keyboard and the different methods of coordinate input. Coordinate input allows you to type exact values into your system to position, scale, or rotate your objects accurately. Coordinates are entered for various X, Y, Z values depending on the type of transformation used. Coordinates are entered in the prompt line found just under the menu bar. Click on the cone to select it without leaving the Xform Move tool. Type 0, 0, 0 in the prompt line, then press the Enter key. The cone moves to the origin. Now type 3, space 2, space 1, and press the Enter key. Notice how this time you left out the commas. You can either use commas or just spaces to separate values in the prompt line. Inputting coordinates in Alias can be accomplished using either absolute or relative values. When entering absolute values, you transform the object to exactly the entered values. With relative values, you transform the object in relation to its current position. With Xform Move still selected, click on the sphere. Type 0, 0, and 5 and press the Enter key. The sphere moves to the exact coordinates of 0, 0, and 5. Now, type 2, 1, and 1, then press the Enter key. Notice how the letters ABS are displayed to indicate that absolute values are being used. The sphere is now at these coordinates. Note that the sphere dropped to the ground since the absolute value in the Z direction is 2. Now type an R, and then again type 2, 1, and 1, and press Enter. The R indicates that you are entering relative values. In the modeling windows, you see that this time the sphere moved in relation to its last position. Note that in addition to entering values for translation, you can also enter values for the rotation and scaling of objects. Click on the cube to pick it. Go to the Xform section of the tool palette and choose Rotate. Enter A for absolute, then 0, 0, and 45, and the cube goes to these values. All transformations in Alias can be controlled by both keyboard input and mouse clicks. You must decide whether interactivity or exact values are most important to you. In general, you'll probably combine both methods of working. When you transform objects, they are transformed based on pivot points. These points represent the anchors of the objects for translating, rotating, and scaling the objects. Click on the sphere to pick it while unpicking the cube. In the front window, dolly in to see more of the sphere. You will find the pivot point at the sphere's center. From the Xform section of the tool palette, select the Scale tool. Click Drag to scale it. The scale will be based on this point. Now go to the Xform section of the tool palette and choose Set Pivot. Click Drag with the right mouse button to move the pivot to the base of the sphere. From the Xform section of the tool palette, select the Scale tool. Click Drag to scale it. The sphere scales based on this new pivot. Any rotations that take place will also take place using the pivot as the center of the rotation axis lines. You can separate the rotation pivot from the scaling pivot, but in general you will keep them together. Pivots are an important part of using the Xform functions, and you should learn to use them to your advantage. You have now learned how to build primitives, transform them, set pivots, and create groups. To experience these ideas firsthand, complete Lesson 2 of the Learning Alias Guide, where you will build a temple using primitives and X-forms. Now let's take a look at how to model using curves and surfaces. Creating curves and surfaces is the foundation for most of the modeling you will be doing in Alias. While primitives give you a good place to start, they are very limited in the range of objects that they can represent. To learn about how to create more sophisticated forms, you will begin by learning how to draw curves by creating a profile curve for a Mexican sombrero. Go to the Curve section of the tool palette and choose New Curve. Click in the title bar of the front window to make it active. Press the Alt key to temporarily turn on grid snapping and place the first CV at the Z-axis, 4 grid squares above the X-axis at point 0, 0, and 4. Because you'll revolve this curve around the Z-axis, either the first or the last point of the curve must lie directly on this axis line. With the Alt key still pressed, place the next CV 1 grid square to the left of the Z-axis, 4 grid squares above the X-axis. Connecting the 2 points is a line known as a hull. The curve itself has not yet been drawn. This is because a degree 3 curve needs at least 4 points to describe it. Place the next 2 points at the following coordinates using grid snapping: -2, 0, and 2, and -3, 0, and 0. Note how the curve appears once you place the 4th point. Place the 5th point at -4, 0, and 0. Now, select Pick Nothing from the tool palette to deselect the curve. At this point, you may notice the curves have several important markers. A square box is used to denote the first CV of the curve. The second CV is shown as a U, and subsequent CVs have a small x. The box marks the first point of the curve, and the U marks the curve direction. The hull line connects the CVs belonging to the curve. The small points that sit directly on the curved surface are known as edit points. The region of the curve between 2 neighboring edit points is known as a span. This curve has 2 spans. Earlier, you learned how the control window turns CVs, edit points, and hulls on or off for curves and surfaces. This feature is useful as your scene becomes more complex, since you can keep the model less cluttered by turning the curve controls off for certain curves. From the display menu, select the controls options. This opens the control window. From the scope menu in the control window, select all. Turn off any options already turned on by unchecking them individually. Click the Go button. Notice that all of the controls on the profile curve have been turned off. Click on the checkbox next to Edit Points. Click Go. The curve's edit points are now visible and can be picked. One advantage of turning controls on and off is that you limit the number of pickable controls. For instance, you can now pick and modify the edit points on this curve, but you cannot pick and edit the CVs. Click the On button next to All, and then click on Go. This turns all the controls back on. Click on the Close button in the upper left of the control window to close it. Often you'll want to continue to work on a curve that has been deselected. Because the sombrero profile still needs more shape, you can add another 2 CVs to it. Select Pick Point Types CV in the tool palette. In the front window, click on the End CV to make it active. Now the CV is highlighted, as well as the end segment of the curve. In the Curve Edit section of the tool palette, select Modify Add Points. The system prompts you to add CVs. Add 2 more CVs by clicking in the area up and to the left of the last CV. Select Pick Nothing to deselect the curve. You can now see the shape of the profile clearly. Generally, you can edit the shape of a curve by modifying the position of the CVs. To refine the shape of the sombrero profile, you can pick and move the 2 end CVs. Select Point Types CV. In the front window, click on the End CV. Select X-Form Move. Click Drag to move the CV around the front window. Enter -5, 0, and 2 to place this CV exactly. At any point, you can use coordinates to place your CVs at exact locations. Click on the second CV from the end to pick it. Place this CV at -5, 0, and 1 using either grid snapping or keyboard input. This places the CV directly below the last CV to reshape the outer edge of the profile. You have now completed the profile curve. This curve can be turned into a surface using a surface creation tool. There are many surface creation tools in Alias. One of the most basic is the revolve tool that takes a profile curve and revolves it around an axis line. To create the surface of the sombrero, you will use the revolve tool. Scroll to the surfaces section of the tool palette and select the revolve options. In the revolve option window, make sure that Z is chosen for the revolve axis and that the sweep angle is set to 360 degrees. Make sure that create history is checked on, then click go. Then click on the profile curve. The curve revolves a full 360 degrees around the Z axis. The revolve axis indicator is visible, shown as a line between two crosses. As well, the revolve degree indicator is shown as a circle with an arrow at one end. The revolve tool maintains construction history for both the position of its axis line and the degree of its revolution. You can edit the history of a revolved surface by using the history indicators. In the front window, dolly and track the view until the hat fills the window. Click on the revolve axis line to pick it. In the front window, click-drag the axis line about one grid square to the right. The revolved surface automatically updates based on the new axis position. Click the bottom cross of the axis line as shown above. Enter 0, 0, and 1 to place this point back on the Z-axis. The revolve is again regenerated using the tilted axis line. Click the top cross of the axis line. Press the Alt key to temporarily turn on grid snapping. In the front window, click-drag the point so it is directly above the origin to reorient the axis. The surface updates to its original position. Now you will edit the angle of revolution for the surface. In the perspective window, click the arrow on the revolve degree circle to make it active. Click-drag to the left in the perspective window. This creates a partial revolve. Type -180 in the command line and press the Enter key to create exactly a half revolve. Next, enter 360 in the command line to recreate a full revolve. A revolve's history can be edited using these special indicators for the axis line and revolve degrees. These items are only available when construction history is still active for a revolved surface. Select Pick Nothing to unpick the surface and remove the revolve indicators. Construction history is also maintained between the construction curve and the resulting surface. This connection exists with all surface creation tools. It gives you flexibility in editing and refining your work. As a result, you can modify the surface by editing the CVs on the original profile curve. Select Point Type CV. Click on the second CV from the top of the sombrero. Select X-Form Move. In the front window, click-drag with the middle mouse button to move the picked CV horizontally. Move it slightly to the left and release the mouse button. The revolved surface is updated. Select Pick Object. Click-drag a pick box around both the sombrero and the construction curve. Next, press the Shift key and click on the surface of the sombrero away from the curve. This unpicks the surface while leaving the curve picked. Select Delete Active. At the prompt, click on the Yes button to break construction history and delete the curve. Earlier you learned that curves can be displayed with controls such as CVs and hulls. Surfaces can also be displayed with these types of controls. From the display menu, select the Control option window. From the Scope pop-up, choose All. Click on the On button next to All and click on Go. CVs and hulls are now displayed on the surface. Close the Control window. Earlier, you edited and refined the shape of a curve using the CVs. A similar technique also applies to surfaces. Select Pick Point Types Hull. In the perspective window, click on the hull at the outer rim of the hat with the middle mouse button. Note how all of the CVs connected by this hull are picked. Select X-Form Move. In the front window, click-drag with the right mouse button to move the hulls down a little bit. You are now controlling one part of the overall surface. Select Pick Nothing, then Pick Point Types Hull. In the perspective window, click on the two hulls below the outer rim hull. Select X-Form Scale. In the front window, click-drag to scale the hulls out a little bit. You can also pick and move some CVs on the surface. Select Pick Nothing, then Pick Point Type CV. In the front window, dolly the view until you see all of the CVs. Click-drag around the two CVs at the far right of the surface, then click-drag around the two CVs at the far left of the surface. Select X4 Move. Click-drag upwards with the right mouse button to reposition these CVs. Note how the surface is only updated in the area next to the picked CVs. By editing the surface controls, you are able to achieve a more freeform shape for the sombrero. In Lesson 3 of the Learning Alias Guide, you will build this sombrero yourself and at the same time model a guitar. The guitar will be created using different types of curve tools such as edit point and key point curves. You can then complete Lesson 4, which introduces you to various surface creation tools. In a computer-generated 3D world, it is possible to go beyond simple wireframe views of your models. With Alias, you are able to achieve photorealistic effects by simulating texture and light in your scene. In this section, you will learn how to create shaders, add lights, and render a scene. Version 6 users should take special note of the new workflow for creating test renderings and the new location of the multi-lister. Shaders are created and assigned in the multi-lister. This important window allows you to organize and edit various shaders, lights, and forces. Shaders contain all the information used to set up a particular material that can then be applied to any number of objects. Go to the Windows menu and choose Multi-Lister Shaders. The multi-lister is like a command center where shaders, lights, and forces are set and applied. The multi-lister has its own menus and includes graphical symbols for the shaders and lights within a project. Right now, the multi-lister only displays the shaders and is now known as the shader lister. Double-click on the default shader icon. This opens a second window called the Shader Editor. This window holds all the numeric parameters that are used to set up a shader. You'll now create and apply shaders into this simple scene. In this scene, there are two walls, a floor surface, a column, and a sphere. You will begin by creating color shaders for the wall, then create a transparent texture for the sphere. You will then create a pattern for the floor and a marble shader for the column. You'll begin with a simple color shader that can be applied to the wall. In the shader lister, go to the Edit menu and choose New Shader. Double-click on the shader's name and change it to Walls. Next, go to the Shader Editor. At the top of the editor is the name of the new shader and the shading model. Currently, the shading model is set to Lambert. In the Shader Editor, go down to the Common Parameters section and click on the patch next to the word Color. This opens the Color Editor. You can now click to pick a color or change the red, green, blue, or the hue, saturation, and value settings. Pick a bright blue color from the color palette. Now click-drag on the value slider to darken the color. The shader in the shader lister now shows the new color. Now go to the modeling window and pick the two walls. Go back to the shader lister and choose Assign Shader from the shading menu. Once you have created a shader, you must assign it to objects in the scene. Now any changes made to the shader will affect the final look of the objects they are assigned to. Go to the Edit menu and choose New Shader. You will use the second shader for the sphere. In the Shader Editor, rename the shader Glass. Next, change the shading model to Fong. This reveals new parameter options in the Shader Editor. Next, go to the Color Editor and make the color black. Return to the Shader Editor and click-drag on the Transparency slider and drag it to create a transparent shader. In the Shader Editor, a gridded pattern appears behind the shader sphere and the transparency is revealed. Since you want the sphere to reflect the room in a ray trace rendering, go to the Shading Parameters section and set the reflectivity to 0.8. This will create a lot of reflectivity. Go to the modeling windows and click on the sphere with the middle mouse button. In the shader lister, go to the shading menu and choose Assign Shader. In addition to setting the color and transparency of a shader, you can use textures to create more complex surface effects. Texture mapping can be applied to the UV parameter space of a surface or to the 3D space of an object using solid textures. You will start by applying a surface texture to the floor. Create a new shader and name it Floor Tiles. In the Shader Editor, change to a Fong shading model. In the Common Shader Parameter section, click on the button labeled Map next to Color. The texture selection window appears, offering you a multitude of texturing possibilities. Click on the checker button and a checker texture appears in the multi-lister. At the same time, the shader editor becomes the texture editor, and you can now edit the parameters of the texture itself. Click on the patch next to Color 1 to make the color editor address this color. Change the color to red. In the shader editor, go to the blur section and set the blur mult to 0.1 so that the texture is sharper. In the modeling windows, pick the floor and then assign the shader from the multi-lister. Now go to the render menu and open the quick render options. Set the quality to high and the shading frequency to 10 and click on go. Notice how the pattern is on the floor with the squares in all directions. Next, you must set up the positioning of the pattern. When working with the surface texture, it is positioned based on the UV parameter space of the surface. Go to the surface placement section of the texture editor. Enter 3 for the U repeat and 3 for the V repeat. Enter 45 for the rotation of the texture. Once again, quick render the scene. Now there are not as many squares and they are rotated. Next, you need to apply a material to the column. Some objects require shaders that appear more like a solid piece of stone or wood. Solid textures create this effect since they position the texture in 3D space instead of the UV parameter space of the surfaces. In the shader lister, go to the Edit menu and select New Shader. In the shader editor, rename the shader Marble and change the shading model to Fong. Now click-drag on the specularity slider to create a sharper highlight since the marble will react strongly to light. In the Common Parameters section, click on the Map button next to Color. In the Texture Selection window, scroll down to the Solids section. Select Marble, and a new marble texture is placed in the multi-lister. The shader editor becomes the texture editor. Go to the Marble Texture Parameter section and change the filler color to a dark gray and the vein color to white. You can also change the vein width and contrast of the pattern. Next, go down to the Noise Parameters section and bump the noise level to 3.0. As you can see, there are many factors that affect the look of the texture. The texture is now set and needs to be assigned to the column. In the modeling windows, pick the column. In the multi-lister, go to the shading menu and choose Assign Shader. Remember that if you don't assign the shader, then it will not be part of the final rendering. Positioning a solid shader is different than a surface texture. With the solid texture, you need to position the shader in 3D space in relation to the actual object. In the shader lister, click on the little icon at the lower right of the solid texture. In the modeling window, you now see a positioning object at the origin. You now want to link it to the column. In the shader editor, go to the 3D placement section. Click on the link button to link the shader to the column. This means that the positioning object moves to the pivot of the column and the two pieces are grouped together. Now click on the surface placement icon in the shader lister to hide the icon. Once again, quick render to see the rendered effect. In addition to mapping basic color and texture, Alias also allows you to create special surfacing effects using textures. You will now add a bump texture to the walls and a special reflectivity map to the floor. Click on the Walls shader in the multi-lister. In the shader editor, scroll down to the Special Effects section and click on the Map button next to Bump. In the Texture Selection window, click on Noise to use this texture. In the Texture Editor window, go to the Noise Texture Parameters section and change the amplitude to 0.15. Go down to the Surface Placement section and change the U repeat and the V repeat to 4. In the shader lister, you can now see that there is a little bit of bump on the shader. Next, click on the floor tile shader in the multi-lister. You will now use a second grid pattern on the floor so that some tiles reflect and some tiles do not. You will notice that many of the parameters in the shader editor have textures mapped. Exciting effects are possible when you begin unleashing the power of these mapping techniques. Click on the Map button next to Reflectivity. Choose the Checker Texture option. To copy the placement parameters from the first checker texture, click on it in the lister. Press the Shift key and click on the U repetition, V repetition, and rotational parameters. Go back to the shader lister, and with the Shift key still pressed, click on the new checker pattern. Choose Copy Parameters. The reflectivity map now matches the color map. Now all the red squares will reflect, while the black squares will remain unreflective. Of course, this effect will only be visible in array trace rendering, since there are no reflections in array cast rendering. As you can see, the options seem endless for all the texture possibilities. You should load some of the textures that ship on the 3D CD and dissect them. Look at how they are built and how the parameters are set. This will give you a good foundation for creating shaders on your own. Once geometry has been created and shaders assigned, you are almost ready for rendering. But before you render, you must set up light sources that will illuminate your objects. Lighting is an important part of setting up a scene, since lighting sets the atmosphere and mood of the final rendered image. In the multi-lister, go to the list menu and choose Lights. Now the shaders are gone and the lights of the scene are shown. Currently there are two lights. These were created when you quick rendered the scene. Click on the second light. The shader editor becomes the light editor. All parameters of the different lights will be set here. In the light editor, you can see that this light is a directional light type. There are 7 light types available in Alias that offer you specific lighting effects. For this light, choose the Spotlight type. Spotlights are lights that have a look at point and a look from point. They have a definable cone of light that can be set to restrict the area of illumination. Open the Active Effects section of the Light Editor and turn Shadows to On. By default, lights do not particularly cast shadows. You must choose this option. In the Common Parameters section of the Light Editor, increase the intensity to 2. Now, minimize the Light Lister and the Light Editor. Go to the Window menu and choose SBD. In the SBD window, you will find the DAG nodes for the spotlight. Just like a camera, a light has an eye point, look at point, and an up vector. Pick the top node of the spotlight. Select X-Form Move and move the light to the top corner of the little room. Now move it to the bottom corner in the top window. Next, pick only the look at vector of the light. Move it in the modeling views until it is pointing at the sphere. Now, maximize the light lister and editor. Scroll down to the Spot View section and click to open. This view now shows the scene from the point of view of the light. Adjust the view icons in the view and you will see the parts of the light move in the modeling views. Scroll up to the Spot Parameters section. Click to turn on the penumbra, then change the penumbra value to -4. The edge of the penumbra is shown in the spot view. The penumbra is the area where the light will soften as it hits the scene. Now change the spread to 60 degrees. Only part of the scene will be lit by the spot when you later render. While lights can be used to light a scene, they can also be used to create special effects such as halos and glows. You'll now place a light inside the glass sphere. Go to the light lister and click on the ambient light to pick it. Now click on the icon in the top left of the light to pick the light in the modeling windows. Select X-Form Move and enter 2, -2, and 2.75 to move the point light to the center of the sphere. In the Light Editor, change the light type to point. Open the Active Effects section and turn Shadows on. Now go to the Glow menu and choose Ball Glow. This will add a little glow to the light. Scroll down to the Glow Effects section under Glow, click on the color patch and change the color to red. Now increase the intensity to 5, the spread to 1.5, and the star level to 3. You are now going to add some fog to this light. Scroll back up to the Active Effects section and choose
Fog Exponential. Scroll back down to Glow Effects and open the fog options. Click on the color patch and give the fog a yellow color. Now change the intensity to 3, the spread to 1.5, the radial noise to 2, and the 2D noise to 3. These two special effects will give the light a unique look when rendered. To see a preview of the effect, look at the icon in the light lister. To see the final results of all the work done so far, you will now render the scene. To see a final rendered image of your scene, you must combine the geometry, shaders, and lights and let the computer calculate the final results. In Alias, you set up a rendering by saving the scene as a scene description language, or SDL file, that acts in much the same way as when a photographer takes a picture and gets a negative. The renderer then takes the SDL file and processes it into a rendering. The main types of rendering in Alias are ray casting and ray tracing. You will now create renderings using both kinds of techniques in order to explore the rendering process. When you were setting up lights and shaders, you often called upon a quick render to test out ideas. You will now take one last look before creating more complex renderings. Go to the Render menu and select the Quick Render options. Turn Glow Pass on and click Go. The resulting quick rendering shows the materials, basic lighting, and the glow in the sphere. You will now use more sophisticated techniques to see a more realistic image of the scene. To set up a rendering, you must begin with the Render Globals. This window lets you set the quality and the size of the rendering. Go to the Render menu and choose Globals. In this window, set the quality to low. Your first rendering should always be a test. It would be a waste to render a high-quality image since you may not like the results. Now go to the image file output section and make sure that 645 is set for the X resolution and 486 is set for the Y resolution. Close the Render Globals. You'll begin with the test rendering of the scene. Go to the Render menu and choose the Render options. In the option window, select the Raycast rendering type, then click on the Test Render option. Set the test resolution to 0.5. Version 6 users will notice that this is a new and faster way of creating test renderings. Click on Go and the rendering begins. To watch the progress of the rendering, select Toggle Render Status from the Display menu. You can now monitor the progress of the rendering. Once it has started to render, you can select Show Render from the Render menu and a visual of the images shown. You can see the glow and the fog and some shadows, but there is something missing. In the real world, the glass would be refracting and the floor would have reflections. You will now ray trace the image to see a more sophisticated result. Before proceeding, you must set the render subdivisions of the objects. Render subdivisions define how many pieces the surface will be broken into when the final rendering occurs. Select Pick All Objects and Lights. Now go to the Windows menu and choose Render Stats. In this window, you can see the render stats for the objects. The default setting is 2 to 4 subdivisions per isoparm patch. You will need higher settings for some of these surfaces. Set 5 to 10 for the sphere and the revolve since they are more complex shapes. Note how by shift selecting both objects from the list, you can change their values at the same time. Set 3 to 6 for the squares since they do not create curves at all. The more subdivisions the better, although too many will create long renderings with only a little visual benefit to the final image. You must balance the need for more subdivisions to the rendering time of the image. You will now ray trace the scene at a larger size. Ray tracing will allow you to render the scene using reflections and refractions. Go to the Render menu and select Render Globals. Set the global quality level to high. Now close this window. Go to the Render menu and select the Render options. Choose the Ray Trace rendering type and turn the Test Rendering section off. Click on Go. You are now placed in the file lister. Name the file Room Ray Trace and click Save SDL. The rendering will now start. Note that this rendering will take quite a bit longer than the first because of several factors. First, the image is bigger and the quality is higher. Second, you have set more render subdivisions. And third, ray tracing calculates reflections and refractions, which can take a long time to calculate depending on how many glass or reflective objects are in the scene. The final image displays some important advantages of ray trace rendering. The crystal ball is now refracting its contents and reflecting its surroundings. The point light is emitting light and casting shadows, which it can't do in a raycast. In addition, the reflectivity map on the floor is evident since the red squares are reflecting while the black squares are not. You are now ready to begin animating objects in your scene. Beyond the 3 dimensions of the modeled world is the 4th dimension of time. By applying this new dimension to objects as they move, squash, and stretch, motion is achieved and the true nature of 3D space is revealed. By animating your scene, you can begin looking above, below, and around your objects as they dance, fly, and even explode. Version 6 users should take note of the new set keyframe default and the ability to cut, copy, and paste keyframes between objects. In this video, you will look at basic animation techniques that will prepare you for animating in Alias. All animation is based on a few important concepts that can be applied equally to animating objects, lights, cameras, CVs, and even shader and light parameters. If you are going to animate in Alias, then you will use keyframes. Keyframes let you record coordinates, values, and parameters at important points in time so that an animation will be formed. To explore some of the possibilities of animating with keyframes, you will begin with the simple sphere. You are now going to create a cycle where the translation, scaling, and rotation of the sphere will be animated using keyframes. Scroll to the Object section of the Tool palette and select the Primitive Cube tool. Place a cube into the scene. Next, select the Primitive Sphere tool. Place this sphere into the scene. Next, go to the Animation menu and select Toggle Time Slider. This opens the time slider that offers you video-like controls for working with time. Change the current frame to frame 1. Go to the Animation menu and choose Set Keyframe. A keyframe is set for frame 1. This is a major change for version 6 users. In the past, the default method of setting keyframes was based on a system prompt instead of the current frame. While the old method is still available, the current frame is the new default used to set keyframes. In the time slider, change the current frame to 10. Now, X-form move the ball in the top window. Go to the Animation menu and choose Set Keyframe. In the time slider, change the current frame to 20. X-form move the ball in the top and front window. At the same time, X-form scale the ball to make it bigger. Go to the Animation menu and choose Set Keyframe. In the time slider, change the current frame to 30. X-form move the ball in the top and front window again. At the same time, non-proportional scale the ball to make it bigger in the X direction. Go to the Animation menu and choose Set Keyframe. This sets the position and scaling for frame 30. In the time slider, change the current frame to 40. Next, X-form move the ball in the top and front windows. At the same time, you want to non-proportional scale the ball to make it smaller in the X direction and wider in the Y direction. Again, go to the Animation menu and choose Set Keyframe. Now go to the Edit menu and select Copy Keyframes. Enter 1 to copy the keyframe information from frame 1. Go to the Edit menu again and select Paste Keyframes. Enter 50 to place the copied information at frame 50. Now change the frame range on the time slider to Use Min-Max. This uses the range between frame 1 and 50. Click on the Play button in the time slider. The ball now transforms over time based on your settings. Note how the cube is not animated since it was never moved and keyframes were never set. Stop the animation. With the slider in the time slider, scroll through the animation. Now enter 30 in the time field. You can now see the ball at frame 30. Since this is where you set one of your keyframes, you can see where you set it. X-form scale the sphere very small. From the animation menu, select Set Keyframe. Click OK to overwrite old keyframes. Click the play button. Now the animation is updated with the new settings. Keyframes will be a vital part of all the animation you will do in Alias. To learn more about setting keyframes, you will look at hierarchical animation and how it can be used to control the animation of an object. Setting keyframes is an important part of all animation in Alias. As animations get more complex, it is important to organize how keyframes are set. In Alias, you will use DAG nodes to set up a hierarchy where each level will represent a different transformation that may be applied to each node. To learn about hierarchical animation, you will again use a sphere. You will now animate this sphere as a bouncing ball. The hierarchy will allow you to set up the motion of the ball, the scaling as it hits the ground, and the rotation as it moves forward. Go to the Object section of the Tool palette and select the Primitive Sphere tool. Press the Alt key and click at the origin. Go to the Windows menu and select SBD. Find the sphere, which will have its upper node already picked. Now go to the Edit menu and select Group. Select X-form Move and enter 0, 0, and 0.5 to move the ball up so that it sits on the ground. The pivot will remain at its center. Group the ball 2 more times. As you already know, a group's pivot point goes to the origin. Therefore, the top 2 nodes have their pivots at the base of the ball. Pick the top node, then go to the Windows menu and select Information window. Rename the node Ball Trans. This node will carry the movement or translation of the hierarchy. Now click on the second node and rename it Ball Scale to indicate the scaling node of the hierarchy. Next, repeat for the third node and call it Ball Rotate to indicate the rotation of the hierarchy. For the fourth node, simply name it Ball. This node will remain untouched during the transformations as the upper nodes do all the work. Close the information window. By splitting the animation into pieces, you will have more control as you work. You will control the parts of the animation using the Parameter Control window. Go to the Animation menu and select Parameter Control to open the Parameter Control window. Each object has 10 parameters: XYZ Translate, XYZ Rotate, XYZ Scale, and Visibility. The Parameter Control window allows you to restrict and choose the parameters you wish to animate so that only the chosen parameters receive keyframes. In the SBD window, pick the Ball Trans node. Note that the Ball Trans parameters appear in the Parameter Control window. By default, all motion parameters are turned on. Turn off all the parameters except Z Translate by clicking in the boxes. A checkmark means that it has been turned on. In the SBD window, pick the next node down, the Ball Scale. The Ball Scale will now be in the Parameter Control window. Turn off all the parameters except Z Scale by clicking in the boxes. In the SBD window, pick the next node down, the Ball Rotate. The Ball Rotate will now be in the Parameter Control window. Turn off all the parameters except Y Rotate by clicking in the boxes. You will start by animating the translation of the ball. The translation animation will be added to the top Ball Trans node of the ball. Click on the Ball Trans node to make it active. In the time slider, set the current frame to frame 10. Go to the Animation menu and select the Set Keyframe options. Set the parameters to local to use the settings from the Parameter Control window. Click on Go, and a keyframe is set for frame 10. This node has now been animated. You can check the SBD to see that the Ball Trans node is shown as a skewed box. Also, the Parameter Control window shows that the Z Translate parameter has received keyframes by skewing the parameter box. In the time slider, go to frame 0. Go to the X-form section of the Tool palette and select Move. Enter 0, 0, and 10 to move the Ball Trans up 10 units. This is where the ball will begin to bounce. Dolly and track in the front window until you can see the ball and the ground. Go to the Animation menu and select Set Keyframe. Now go to the Edit menu and select Copy Keyframes. Enter 0 and 10 to copy the keyframes at frames 0 and 10. Next, go to the Edit menu and select Paste Keyframes. Type 20 to place a copy at frame 20, 4 to make 4 copies, and 10 to specify the gap between the copies. Press the Enter key. Note that even if you had translated the ball in the X or Y directions, only the Z value would be recorded. When using parameters to animate, you must be sure which parameters need to be animated and set them accordingly. If you don't set the parameter, then a keyframe will not be recorded. In the time slider, click on the play button to have the animation playback in the modeling windows. Click on the stop button to stop the playback. Now return to frame 0. You'll note that the ball's movement is smooth and floats from keyframe to keyframe instead of the hard hitting you would expect of a bouncing ball. You will have to adjust the action curves between the keyframes. You will also adjust the height of the ball at each bounce to make it look more realistic. To adjust the action curves of an animation, you need to use the Action window. This window displays a graph that maps the value of a parameter to time. Go to the Animation menu and select Action window. In the Action Window Views menu, select Look At to see the Z-Translate action curve completely. Now go to the Pick menu and select Keyframes. Click drag a marquee around all the keyframes at Z equals 0. Go to the Tangent Type menu and select Fast Segment In. You will see that the character of the curve changes as it goes towards the keyframes. Fast Segment In makes an action curve accelerate towards a keyframe. Go to the Tangent Type menu and select Fast Segment Out. That same character has now been added to the action curves leaving keyframes. Fast Segment Out allows an action curve to accelerate from a keyframe. From the Action window menu, select Pick Nothing, then Pick Keyframe. Click on the keyframe at frame 20, then select X-Form Move. Enter 20 and 8 to move the keyframe to a Z value of 8. The first bounce will only reach a height of 8 units. Note that the coordinates being entered map time in frames against the Z translation of the ball. Now select Pick Nothing, then Pick Keyframe, and click on the keyframe at frame 40. Now select X-Form Move and enter a position of 40 and 5 to make the second bounce reach a height of 5 units. Repeat these actions for the keyframes at frames 60 and 80 and move them to positions of 60 and 2 and 80 and 1 respectively. The ball will now bounce less and less with time. Note how the action curve resembles the look of a ball bouncing. There is often a direct correlation between the look of an action's curve and its motion in the scene. Close the Action window. In the time slider, click on the play button to have the animation playback in the modeling windows. The ball will bounce 5 times in progressively smaller bounces. Note how the ball hits the ground plane hard but changes direction softly at its peaks. Click on the Stop button to stop the playback, then click on the Go to First button to return to frame 0. You will now give the ball some lateral movement by animating it in the X direction. This action requires that you change your parameter settings for the selected node from Z translation to X translation. This process of choosing a parameter, animating it, then moving to another parameter is a good way of slowly building up an animation while maintaining control over the parts. Click in the Parameter Control window, turn off the Z Translate, and turn on the X Translate. With Ball Trans still active, select Set Keyframe. In the time slider, go to frame 90. Select X-Form Move and enter 20 to move the ball in the X direction. This will represent the range of the movement forward. Select Set Keyframe. The Ball Trans node will now move between 0 to 20 in the X direction over 90 frames. This movement will be in addition to the movement in the Z direction that was set earlier. Note how by setting keyframes for the X and Z coordinates separately, you could use different keyframe settings for each parameter. This allows you more flexibility in your work and uses less keyframes. Click on the play button in the time slider to have the animation playback in the modeling window. Again, the ball will still bounce 5 times in progressively smaller bounces, for the new keyframes will not have disturbed the Z Translate animation, even though the ball is now moving forward. Use the camera icons in the perspective window title bar to orient the camera so that the ball drops in at the top of the screen and leaves the screen at the right during the 5th bounce. Once you are finished, click on the stop button and return to frame 0. Having set the translation of the ball, you will now scale the ball every time it hits the ground plane. You will use the ball scale node to animate the scaling. Because you grouped with the pivot point at the bottom of the ball for the ball scale node, the ball will compress to this point, maintaining contact with the ground plane. Select Pick Object and click on the ball scale node in the SBD window. You can only pick middle nodes of hierarchies in the SBD window, or you can type the object name on the prompt line. Go to the Animation menu and open the Set Keyframe options. Change the in-tangent and out-tangent types to linear. Earlier, you changed the tangent type in the Action window. You can also set the tangent type before capturing keyframes. Click on Save. In the time slider, go to frame 8. Select Set Keyframe. Now in the time slider, go to frame 12. Again, select Set Keyframe. Now go to frame 10. Go to the X-Form section of the tool palette and select the non-proportional scale tool. In the front window, click-drag using the right mouse button to squish the ball scale node in the Z direction. Select Set Keyframe. Now go to the Edit menu and select Copy Keyframes. Enter 8 and 12 to copy the keyframes from within this frame range. Go to the Edit menu and select Paste Keyframes. Enter 28, 3, and 16 to paste the keyframes at frame 28 while making 3 copies with a gap of 16 frames. Click on the Play button on the time slider to have the animation playback in the modeling windows. Press the Stop button to halt the playback. Return to frame 0 using the Go to First button. For the final addition to the ball's movement, you will animate the rotation of the ball. Like the X translate, the Y rotate just needs 2 keyframes to allow the beach ball to rotate throughout the animation. You make sure the rotation is constant by setting the action curve to have a linear in and out tangent. Select Pick Object and click on the Ball Rotate node in the SBD window. Select Set Keyframe to set a keyframe at frame 0. Since there has been no rotation applied to this node, a rotation value of 0 was set for this frame. In the time slider, go to frame 90. Select X-Form Rotate and enter 0, 720, and 0 to rotate the node 2 full circles. Note that the model of the sphere appears unchanged because it rotated twice around. Select Set Keyframe. Press play to have the animation playback in the modeling windows. You now have a good idea of how to animate using hierarchical nodes. To learn more about animating with Alias, you should continue with the lessons in the Learning Alias guide. In all animation, keyframes, the action window, and hierarchical nodes will come into play, and you should learn to master these important concepts. The position of lights, cameras, and CVs can all be animated using these methods. You can also animate the parameters found in the light and shader editors. In the Learning Alias guide, there are lessons that will introduce you to metamorphosis, deformation, clusters, and inverse kinematics. As you complete these lessons, take note how the basic concepts of keyframing often come into play. Well, you have now learned a great deal and deserve a rest before you begin tackling the tutorial lessons. As you have seen, Alias contains everything you need to model, render, and animate in a photorealistic world. Now that you have an understanding of where the basic tools and functions reside, you can begin working on your own. Good luck and welcome again to the world of Alias Wavefront.